Hi guys, welcome back to our data science series. In this episode, we will dive into one of the most critical aspects of machine learning, which is model evaluation and optimization. So, today we will cover cross validation technique and hyperparameter tuning using GridSearchCV and randomized search CV. So stick around because I will also show you the practical examples, including tips to optimize your code for faster results. Okay, so let's begin with the model evaluation. When you guys building machine learning models, so it's essential to assess how well your model generalized to unseen data. That's where cross validation comes in. So cross validation is a technique that splits the data into multiple subsets. The model trains on some of these subsets and validates on the others. Let me show you a simple example using Python. Okay, so first of all, we need to import libraries from sklearn dot model selection, import cross validation score. Okay, now the second one is from sklearn dot ensemble, import random forest regressor. Okay, now the third one is datasets. We use built-in datasets of California housing. So import fetch California housing. Okay, so the fourth one is again from sklearn. Now dot to pre-processing. Okay, import standard scalar. Okay, now the fifth one is from sklearn dot pipeline, import make pipeline. Okay, now after this we need to load a California housing dataset. Okay, so for this declare a variable data equal to, so fetch a California housing, so as underscore frame equal to true. Okay, now after this x y equal to data dot data, and the second one is data dot target. Okay, now define the pipeline for scaling and model. Okay, so for this we declare a variable pipeline equal to make underscore pipeline. Now use standard scalar, which is the first argument, and the second one is random forest regressor. Now pass the argument in random forest regressor, which is random state, which is equal to 42. Okay, so next perform cross validation. Five-fold cross validation. So for this we use CV underscore scores equal to cross val score. Now it will take the arguments. The first one is pipeline, the second one is x, the third one is y, and the fourth one is CV equal to 5, and the last one is scoring equal to R2. Okay, now after this print the message. So cross validation R square score, now comma CV under score scores. Okay, now the last one is print, which is mean R square score, which is CV scores dot mean. Now run the code. It will take some time, so I will fast the video after running the code. Now here you can see the cross validation R square scores and mean of the R square score. So this code performs five-fold cross validation on the California housing dataset and calculates the R square score for each fold. So cross validation ensures that our model performs well across different splits of the data. Okay, now the next one is the hyperparameter tuning. So let's optimize the performance of our machine learning models. Hyperparameter tuning help us find the best parameters for our model. For example, the number of trees in the random forest or the depth of each tree. So the next one is GridSearchCV. GridSearchCV performs an exhaustive search over all parameter combinations. It's powerful but can take time with large datasets or many parameters. So let's see the example of GridSearchCV. So first we import the library from sklearn learn dot model selection import GridSearchCV. Okay, now parameter grid equal to, now the first one is random forest regressor and estimators. So for this we use the first one is 50, 100 and 200. Okay, the third one is random forest regressor max depth. For this we use, the first one is none, the second one is 10 and 20. Okay, the third one is random forest regressor minimum sample split. So for this we use 2, 5 and 10. Okay, now after this grid search, which is equal to grid search CV. Now it will take some arguments. The first one is pipeline. The second one is parameter grid, which is equal to param grid. Uh, it's not grid, it's a grid. Okay, the third one is CV equal to 3, scoring equal to R square. Now number of jobs, which is equal to -1. So -1, it uses all the CPU cores. So the recommended is -1. I will also comment here all CPU cores. Okay, now after this verbose equal to 3. So it shows the progress. Okay, now after this use the grid search dot fit. Now pass the argument which is x and y. Okay, now print. So best parameters. So here grid search dot best params. Okay, now after this print, So here we use best r square score grid search dot best score, and now run the code. Okay, now here you can see this code takes time 9 minutes and 6.6 seconds. So the best parameters as you can see in the result, and best r square score is 0.65. So this grid search CV implementations search through all combination of the n estimators, max depth and minimum sample split to find the best configuration for our random forest model. Okay, now the next one is randomized search CV. As you can see, the grid search CV feels slow because it takes too much time. So randomized search CV is faster than grid search CV. So it samples a fixed number of parameter combinations from the grid and reducing computation time. So let's discuss it using example. Okay, first we import from sklearn our library dot model selection. Now import randomized search CV, and the second one is import numpy as np. Okay, now define the hyperparameters. Grid with wider range. Okay, so param equal to, okay, now again random forest regressor, or it's better to copy these three lines. We use the same lines to check the result. Okay, now after this here we use random search, which is equal to randomized search CV. Now the first one is pipeline, the second one is param distributions, which is equal to param dist. Okay, now the next one is the number of tires, so which is equal to 10. It just use only test random combinations. Okay, so after this here we use CV equal to 3. Okay, after this here we use scoring, which is r2 r square. Okay, and the number of cores -1. We use all the CPU cores, and show the detail verbose equal to 3, and random state equal to 42. Okay, now after this random search dot fit, the argument is x and y. Okay, now print, again I am copying these two lines and paste it here. So we change this random search dot best params, and also change this one as well, random search dot best score. Okay, now run the code. Now here you can see fitting 3 folds for each of 10 candidates, so totaling 30 fits. So here I'm pause the video. I will show you the result after completion the process. Okay, now here you can see it takes only 2 minutes and 51.7 seconds. So as you notice how randomized search CV runs faster by sampling fewer parameters combinations. So you can also control the number of iteration with the entires with this parameter. I'm here using 10, so you can change it and see the result. So what should be the best practice for speeding up tuning? So some tips to speed up hyperparameters tuning is, so use fewer folds in cross validations during initial experiments, like three folds instead of five. The second one is optimized smaller dataset first and reduce the parameter grid size, and always set the number of cores, which utilize all the CPU cores to speed up the process. So, to recap, we learned about cross validation techniques to evaluate model, grid search CV for exhaustive hyperparameters tuning, and the last one is a randomized search CV for faster tuning. So, apply these techniques to ensure your model are optimized and ready for production. So, I will share this file with you guys. You will find the link in the description. So, thanks for watching. Don't forget to like, comment, and subscribe for more data science content. So, check out the description for the code and resources. See you in the next episode.